Hey, what's going on? Y'all hear me okay? Test. Cool. Alright, awesome. What's going on, Cosmodium and Coco Daco? It's been quite a while since I streamed. I think like 1.5 months. Basically just got off of about 1.5 months of traveling and conferences and a bunch of stuff, so that's the reason I haven't really been around a ton, but hoping going forward for the rest of the summer won't be as busy, so I'll be able to come hang out a lot more. This is also the first time we've streamed during the week, so usually we do Saturdays, but this Saturday and all the next Saturdays I have are quite busy, so I just wanted to get on here and see y'all. So just to kind of recap, I was working on some red team tool analysis. So we looked at 2 different tools. One's called Sliver, which is a red team tool C2 framework written in Golang. So last stream we generated payloads, various plain text and obfuscated payloads, and then we're looking at those in IDA. And then the other C2 framework we're looking at is called Havoc. So Havoc is written in C, and it is not obfuscated by default. So they do not integrate obfuscation within their build pipeline, whereas we determined last stream that Sliver uses a project that is called Garble. I think I have it open here. And basically how Garble works is it will do some obfuscation of function names and strings. So within the binary itself, it looks very obfuscated, and it's actually quite difficult to reverse engineer with that obfuscation in place. So this stream, I kind of wanted to mess around. There was a post from Sergey that looked at the Bandit Stealer that was obfuscated with the same obfuscator, and he integrated Unicorn to perform some emulation. So I kind of wanted to see if we could do something like that, or even get to the point of fingerprinting the obfuscated functions in IDA. Going good. Saw your YouTube in my feed the other day. Followed your Twitch. Awesome. Yeah. Welcome. So that's one thing I wanted to look at. And then another thing I've been doing is essentially getting the Binary Ninja database up to speed with where I wanted it to be for the Havoc payload. So you may recall that there was a bunch of different hashing obfuscation that was done in place at runtime in order to resolve a bunch of Windows API functions. So I was looking through and marking up these tables similar to what I was doing on stream before. So just to kind of review how this obfuscation worked, there was these stack strings that would construct a stack string. So this is advanced API 32.dll, I believe. And then it would use that it would walk that DLL in memory and then resolve those functions associated with that DLL using this hash function. So we got to the point where we were able to resolve these with HashDB, so that OA Labs plugin, and this was pretty straightforward to get the function recovery working. And then I kind of went over how I constructed these global function tables that are referenced here. And then these global function tables are referenced throughout the binary. So I can show you an example of that. So like this local alloc call, for example. So this is basically once we reconstruct those function tables using this global variable, we can just get all the cross references for that global variable and then see these where these functions are used after they're resolved within the binary. So kind of cool. Again, we have the source code for Havoc because it's just on GitHub, but I kind of wanted to see what we could recover ourselves from the binary standpoint. So yeah, that's the gist of it for the functions. So I'm just gonna do mark this as MW resolve advanced API 32, and then I was actually writing some automation to help me with this. So there's a bunch of different tasks that I had been doing in this particular function, or in these particular types of functions, where I would resolve the hash using hashdb, then I would have to mark that up using the enum, and then recover the variable assignment here, and then assign it to the global struct. So that was just a lot of manual work. So I was seeing if I could automate that. So if I go to my snippet editor here, I have this map enums automation, and I was also messing around with this traverse API. So if you saw the old streams, I was using a different binary ninja function to traverse the high level IL representation here, and that was deprecated. So now the new function that you're supposed to be using is called traverse. So if I go to the docs for that, it's pretty straightforward. Basically, the only difference is that, let's do traverse. It just says iterates through instructions and the high-level instruction and calls the callback function for each instruction and sub-instruction. So all I'm using it for here is to iterate through every instruction within this function and then look for a call. So in this instance, it's looking for the object of high-level IL call. And then I'm checking if the first operand within that call is this integer, which is the call to MW hash function. And then if I do find that, then I return the hash value. And then I look up the hashes that I resolved using hashdb for each enum. And then I basically write that to this variable assignment here. So another thing I wanted to mess around with, if we want to, is assigning these variable names that I've generated here. So that automation will basically rename all of these function variables, or all these variables within the function rather. And then basically I want to write automation to do the second step, which is copying the struct name to this field name. So basically it would just automate every step of me having to manually mark up these hashes in this function. And it's basically just me getting used to the binary ninja Python API. So just some ideas for today. I think there's also some stuff we can look at with the embedded configuration structure within Havoc. So as we saw last stream, it is not obfuscated. So if I go back here to our main, then I believe we have this dynamic function resolution. I know it parses the structures first, so I probably marked it up. Parse config, yeah. So again, this is kind of stuff we did last stream, but I cleaned everything up before this stream. And I basically wanted the code to look very similar to the source code. So we resolved a lot of these structures and these walking functions ourselves last stream, but I just wanted to confirm I was on the right track. And so I looked at the Havoc code. So let me grab that here. So I kept seeing these. One sec. So yeah, what's nice about obviously having the source code is if there's anything we're unsure about when we're reversing an actual binary that has been created using this, then we can check it. But what I did want to look at is the parsing code for the config. So like you can see here, these are the function resolution steps that are being taken for those obfuscated imports. And then, why Binary Ninja over other SRE tools? I haven't used it. Might try it. To be honest, I've just kind of been trying to use tools that are not IDA because I've been using IDA for so long. So I've been using IDA for like 7 years probably. So it's kind of just trying out the different tools, and they have a really nice Python API. So that's the main reason. But I will be using IDA. What do you use, Cosmodium? I'm trying to organize my windows here. Okay, so yeah, basically I got to the point where, okay, yeah, so I was interested in these walking functions because essentially the config is just a flat blob. So if we look at this global variable here, we were manually reversing this blob last time. So we got to the point where, okay, we got a two injection hosts, we had some unknown Boolean flags. Basically, we were just trying to reconstruct this config. So, and the interesting part was that these are like not delimited values, they're just raw values. And sorry, I shouldn't drink Coke while I'm streaming. The delimited values, or sorry, the non-delimited values are walked using these walking functions. So we kind of determined that last stream, where they were essentially acquiring a integer or a D word for each call with this argument, which is passing the configuration address as a pointer. And then it was just acquiring a D word, so an int 32t here, and then assigning that to a variable and then returning that value. So basically we determined that this was an integer walking function. I'm trying to get, okay, hold on, let me go back through the comments, the chat, I mean. So yeah, Ghidra is also really good. Again, I kind of want to use Ghidra more. It has a ton of really good features that I want to make use of. Even like their new diffing feature is really cool. So I definitely want to use Ghidra more. I believe Binary Ninja has a pseudo C representation option. Why do you use the high level IL? So again, something I'm just trying to get used to, but yeah, a lot of people use the pseudo C. So like you see how it's pretty clean looking right now. If I set pseudo C, I guess it still doesn't look too bad, but it just kind of gets rid of these casts, and then it not hides, but it just has a different representation for certain C syntax. It's just basically their more enriched representation of the code in their intermediate language. So I think like Jordan and the Binja staff would argue that it is better than the pseudo C representation, but I'm kind of indifferent, to be honest. And by Binary Ninja staff, I mean Vector 35. But yeah, I'm just trying to get used to it because I do find it useful. Like this is a 0 extend, so like that's more verbose than just a cast in C, right? So like seeing that this is cast as a UN64T doesn't necessarily provide a good indication that that is a 0 extend keyword, if it makes sense. Yeah. Sidekick is pretty good. I think I'm not using it as well or like as correctly as intended. So like I did a video on Sidekick on our YouTube channel. Well, maybe let's link that real quick. So this one's Sidekick, and basically it goes over some basic functionality of Sidekick, and we do go over the automation piece. Anyways, we won't focus on that right now, but it is quite useful for generating scripts. So again, we kind of go over that in the video too, so that seems nice. You bought Sidekick after, oh cool, nice. Yeah, sorry, so where I was going with the indexer and why I didn't, or I wanted to say I didn't cover it in the video, but it seems really useful. But two, I think the model that the indexer uses is a lot better at writing code than like the chat interface, which is what I use in the video. So that's what I just wanted to mention. So that's where I was going with that. But yeah, so anyways, so that's all to say that, so I believe this is also, again, this was a 32-bit. We can look at the code, but basically this would be getting the injection target length. So I'll just double check. Okay, daemon config, so this is where it's parsed. Parser get bytes. Okay, so the second parameter is 32 alloc. Yeah, okay. So that was the correct function name. But this is actually the length. So this might be getting optimized out by Binja, because I'm not seeing this updated anywhere. Let's look at the code again. Yeah, parser get bytes, length. It's getting a length of 0 bytes. That's probably not right. Okay, so that's good that it's not getting optimized out by Binja. But that's why I didn't know what that variable was, is because it's just assigned 0, but whatever. So it's getting 0 bytes, so maybe it's getting the adjacent length, I suspect, if it's provided 0. I guess we could just look at the code. Sorry, I keep looking over because my camera's in the way of my dock on the right hand side, which is not optimal, but if you're wondering why I keep doing that. So let's check out the definition here. Definition. Oh, so it just defaults to reading 4 and then it uses that as the length. Yeah, okay. So that's kind of what I thought, because this initial value is being, whatever. We don't have to focus on this too much. I'm getting into the, trying to get it. Are you doing a live stream where the music itself is a live stream? Yes, I am. Oh, hey, how's it going? Sharkbait. Thanks for joining. I always forget to post the stuff in the YegSec Slack, but I'm glad you're here. Okay, so let's see. Oh, cool. Thank you for doing that. Yeah, I need to get like a bot that'll just post it everywhere, but maybe at some point. Okay, anyways, that's all to say that this was getting the injection target length, and then it was copying these bytes, and so I marked up all of these config parsing functions. So this is important because this is essentially the structure of the configuration itself. So if I go back to this config struct, maybe I can just open this in a separate window and then not have these synchronize. Oh no, I already had it down here, right? Yeah, okay, so the next thing I wanted to do, because I marked up all of these configuration items, so it's kind of confusing because there's the config bytes that are red, which are these, but then once they're parsed, they're assigned to a global structure, which is this global function data structure. That's what I called it. So this structure is a little bit different than the actual structure that's parsed because it resides in memory differently than it does as it's stored in the binary itself, if that makes sense. This stuff reminds me. Yeah, it's okay. I still feel like I know nothing about computers. So, okay, so if we look at the config structure, so we have the config structure down here, and this is the representation as to how it would reside on disk, if that makes sense. So I just basically wanted to mark these up. So the first walk we have is a sleep. So this uint32 is actually a sleep. So this is going to be how many seconds, I believe, pass between the contact of the command and control server. Jitter is probably some sort of, I would need to look at the config items, but I think this is going to be the, I believe you can enable some sort of differentiating factor, because if your implant was contacting the C2 at a constant iteration, that might be some sort of weird network indicator that people can use. So alloc. Again, not entirely sure. Wait, sorry, I messed that up. So alloc x, let's see. This is the length of okay, so by default, it will inject into SVC host. So these are essentially the injection targets. So these are just the injection target lengths. So injection target, oh my god, I keep messing this up. Okay, so we'll do that. Inch target length, 32. Then we'll do inch target length, 64. So there's just obviously different paths for the 64-bit version or the 32-bit version of SVC host. And then I kind of wanted to fix this data type because obviously it's not a character type. So if we do like, I know I messed around with this last stream. Maybe I'll save it for now so I can make more progress. Okay, so we have the injection target length. We have that copy. We have both copies. And then we're going to walk the config again. So this is going to be the sleep mask and the sleep jump bypass. So these are all anti-analysis tricks. So you have, more often than not, you'll have a sleep function that is hooked by sandboxes. So let me back up. So malware sandboxes usually do hooking of some kind. And by that, I mean they will hook Windows API functions in memory that are commonly used by malware in order to do something. And a lot of malware will have a sleep in which they'll basically not perform any actions for X amount of time in order to avoid a lot of these automated sandboxes. And people who develop sandboxes know this, so then they'll hook the sleep call and they'll try and make it small so then they can avoid those types of techniques. But then red team tool developers and these different framework developers know that they'll try and hook sleep, so then they'll try and use different methods to get around that. So this is one of those methods. So it's obviously the cat and mouse stuff. Sleep jump bypass, stack spoof. Okay, so maybe I had the kill date wrong here. Proxy landing. I assume this is like some sort of function proxy stuff. I need to look at how Havoc functions internally more. So sysindirect, yeah, I think this is. So you can also enable some syscall indirect functionality. So like you can do indirect syscalls. So again, this all has to do with hooking that's done by antivirus and stuff. So I know it does have indirect syscall functionality because that was in the builder that we looked at a couple streams ago. So then we have AMC ETW patching, download chunk size. Now we have the kill date. So that was one thing that we found last stream, where it'll basically exit the thread if the kill date has surpassed. So sometimes if your implant is found after X amount of time, you won't really want to let your implant run after a certain date or whatever. So that's what that's for. Sorry for the stupid question. Do you show at the start of the video how to compile Havoc? Yeah. So again, that'll be on the YouTube channel. So I think it's this one. I have a playlist for this whole stream series I'm doing, so I'll just link that. Confuser. Okay, so yeah, no problem. All right, so let's look at the. Sorry, I'm just trying to concentrate because I don't want to miss a config item. Walk int. Oh, is this 64-bit? Because that's going to make a big difference. Working hours. No, I don't think it is. Because we have working hours. This might be a mask or something. Because I don't know how you'd fit the designated working hours within an integer, but HTTP method length. And then the HTTP method. I'll be binging this. Yeah, sounds good. Yeah, I also cut out a lot of stuff from like pauses and breaks that I take and things like that. So they're a lot more condensed than the stream itself. Okay, cool. So we're on the right track here. So there's another integer. So this is all HTTP method stuff. Okay, host rotations. So that's that. And then we have the number of hosts, I believe. Host, null pointer. I believe this should be hosts because there's only one. And then this will be the length. And then this will be the 1E. That would be a massive value. So maybe I did that. E would just be 30 characters, which is probably what this is. Maybe it's just the wrong format. Would that be unpacked and that, whatever, doesn't really matter. And then this is gonna be a character array again. Okay, so we actually want this to be, there we go, that's what I was looking for. Sorry about that. So we actually want this to be, so D0 is the host length. Then we want this to be a character array. Of length 1E. I guess it wouldn't be always 1E, but you know. We can worry about that later. When we're actually writing the parsing code. So we want this to be, oh, so this is a word, that's why. So let's make host length a word. And then I want host length to be a word. And let's just make this another word that I'm not entirely sure what it is yet. Enabled maybe. Okay, cool. How y'all doing? Okay, yeah, let's just move on. I'll show you what I was gonna do with this, because it's taking forever. Okay, so if we go to the, so let's write some new automation here, and we'll do a new snippet. We'll call this parse Havoc, and Python shebang. That's okay. User bin. What's the new one? And Python 3. And then we don't really need to import anything either. So this is the, for those of you not familiar with Binary Ninja, this is the snippets UI. So this is basically allowing me to write scripts for my Binary Ninja instance here. So I am curious if I can just access that variable in here, but I believe I'll have to get the entirety of the struct. So we just do read, and then we'll want to get the actual size of the struct here, and then this minus this, like that. So these are all of the configuration bytes. So let's do, we'll write something later to basically, here, I'll make this a little bit more readable here. So we'll do start struct and then end struct. I'll just call this like config structure offsets. And we can write something to generically identify those offsets using the binary ninja API, but for now let's just do that, and then we'll say start struct, and we want to call this struct length, and then we'll do struct length. Hey Russian Panda, thanks for the follow. How's it going? I really liked your blog on the more eggs stuff. If that was you, I can't remember if it was you or somebody else on your team. Okay, so let's do struct bytes. Okay, and then we're gonna do struct unpack. I don't know. Oh, nice, that's awesome. Okay, so basically we'll use struct unpack for this. So if you're not familiar with Python, basically what struct unpack does is it will take a modifier here, or I don't know what that's actually referred to. We'll do struct Python 3. Yeah, it's just a format string, I guess. And so given 4 bytes, so we'll do 4, then it will extract this for us. So if we do this in this REPL, this should work. Yeah, so that first config item here, sleep, is 2. So I'm guessing there's probably a way to take the struct that we've already made here, or partially made, and then apply it to these bytes using their API directly, which I need to figure out because I think that would be a lot better. Oh, cool. Thanks so much for recommending it. That's really cool. And then we can access that integer. So the fact that it's an integer is why we use this format string here, so the I. But there's a whole bunch of format specifiers for different sizes of data. So if we have like the character, or, and then obviously we'll handle the signedness of the different data, if it's a short, etc. So we just basically want to specify these format strings and then access values of that length to unpack from the bytes that we're extracting from the database. So basically I just want to kind of parse these to the point of getting to the C2. So if we copy these, should I write these manually or should I do it using automation? Should I write Python to parse this? But what if we get stuck in the rabbit hole of me just trying to automate all the automation? Let's try it. So we can do it here. So say we have this like giant struct blob. Then yeah, I think we can just actually manually mark this up, but I just don't want to screw it up. Okay, so I'll do yeah, exactly, Cosmodium. I always get stuck in those traps in these streams, and then like to me, I was like, oh, it'll just take me a few minutes to mark up that structure. But it's obviously, I'm kind of slow with the Binja UI, so that's why it was taking me forever. Okay, so 0, so this will be the sleep. The jitter, and yes, I could do this in the actual dictionary initialization, but whatever. Okay, and then let's print it out so far. Okay, now let's see if the injection target was 64 bytes, I believe it was. Yeah, hex 40, which is 64. So then we'll do this. So we actually need to do the byte times the injection length. Right. Injection target length. And then we need to do the bytes up to 20 up to the 20 plus injection target length. That looks pretty gross. Did I spell injection target length wrong? I did. Oh, because I am doing silly stuff. Injection target 32. And we'll just make a final string here of that guy. We'll just call this bytes and inch target bytes. There's one 16 LE. I can't remember. There we go. UTF-16 LE. Why does Windows have to make their own character encodings? I don't know. And then we'll do our inch target 32, inch target length 64. It's a function, so we don't have to have crazy gross code. Okay. Well, let's make sure this works. So we'll be getting more than one string. Okay, there we go. Now it's nice in another function. And then we can just do, this is why these flat configs are annoying, because you basically just have to parse these manually like this, which is kind of gross. I guess we could do this in like a single struct unpack. I don't know, I should probably stop, just keep refactoring this. Otherwise we're never gonna get it done, so. Jitter. So we actually want this to be execute. And this to be injection target length. And then like that. Okay. So then we can do the same thing. This is just like the characters are variables, so I can't do that in an unpack. So I'll have to do the next one. Can we leave here? Why are you parsing those infos? So this is a piece of malware, essentially, like a red team tool that people use in offensive security. So I'm just writing this so I can basically take these pieces of malware and then extract this information automatically, if that makes sense. Have you done any malware analysis before, Spare? 4 times. There we go. I should probably stop copying and pasting. All right, we're almost there. We're almost to the IP address. I know this is crazy boring, and but we'll get there. 3, and then, so I don't know if diffuser, you're still around, but this is why this is an instance where we can't use the multiple, simply because there's different data sizes in here. So we have an integer, 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 and then word, so, or short, int, and then a short is going to be h. Let's do that. And then it'll be 4 times 3 plus 2. So I may be wrong, that might not be a word. Okay. So we'll probably have to modify this for the times where there are more than one host, because this goes into a for loop, but just as a POC, let's do this. Three, and by config 3, I mean extract string. Okay, HTTP method length, host length. And then we have current offset being incremented by that host length. Add. Okay, and then we get our host. So it took us a while to get there, but basically I just wanted to make sure that we were extracting correctly as my mic goes flying. And we have here. So what I wanted to do next, and will probably be a lot more fun, is if we can actually find a few more Havoc samples, parse them, and then run it against our little piece of code here. So, and then we could probably generalize this to the point of us identifying these struct offsets as well. So let's do that. So what I wanted to use is the unpack me Yara editor to make a Yara sig here. And then I'm gonna do a hunt for this rule to see if we can find more samples. So I didn't do this pre-stream, so I'm not sure if this will actually work, but it's probably worth a shot. So there's a whole bunch of different ways that we can identify Havoc samples. I'll probably write a code signature to detect some of these functions, and then we could probably generalize them based on the content of those functions. So if we, for example, go back to our dynamic function resolution stuff here, like all of these hashes will be in every single Havoc sample, but there might be crossover since this is a known hashing algorithm. So that could be one good way. Even the parsing, the config parsing code would be good, or their custom walking code would be good for walking those different data sizes in the config. Another way, or another really easy way probably, is to actually just look at those config contents and then match on those. So like these wide string bytes that are adjacent, this would be obviously the default injection target, so that would differ, but if we used these bytes, that would probably be a really easy signature. So copy as raw hex. Is that going to give me the bytes? Yeah, okay, cool. So we probably don't have to do all of them, but let's just do invoke Havoc injection target, and then we'll just say detects Havoc implants with default injection target in their configuration. So I don't really know how this editor works, but let's there's revisions. Okay, cool. So you just do, yeah, okay. We'll do meta. I don't know, we have to put any metadata. Then we'll do, this is not a great rule, but that's okay. And we could probably do the leading length. That would be good to include as well. So yeah, these 40 bytes. Yeah, let's just do like copy as raw hex. So like basically the odds of a length being followed by the beginning of the SVC host string are probably quite unique. And then if we combine that with something like the, let's see, maybe one of those hashes, then we can look at a more complex approach. So even these stack string operations would be nice. So the function preamble, and then we have these moves and then pushes, like this sequence, not the call, but call followed by, or the move followed by another move with move byte onto this RSP offset. Let's try that. Okay, and then we'll do, so ideally you want to mask any operations that could be changed by the compiler or any registers. Yeah, we're finally doing something more fun than parsing structures. But this will probably do, since this is going to be the default build. And we'll just do all of them. And then rule validation. There's a bunch of cool like unpacking stuff I haven't used yet. No results available. Submit rule for validation. Okay. So we can make this a okay, how do I save it? Save? There's a giant save button. Should we try with Yara X? I don't really care if it validate. Alright, it passed everything. That's good. B94C, I just want to double check that off. B94C, yeah, okay, cool. 88. Okay. So, and then usually I like to put little comments just indicating that what these operations are. So it was 4C, B94C, okay. So I'm just gonna copy the operations that we're detecting here. And then we can just say that this is the SVC host beginning. Write that out. So followed by, or wait, injection process string length followed by SVC host path is present by default in Havoc configs or something like that. Okay, I'm just gonna validate it again. I'm sure it's fine. I have to save it, and then I can share it with. Ooh, cool. There's revision history. That's nice. And then they have like this little share icon next to it. That's cute. All right, let's do a hunt. Labeled, unlabeled, packed files. No. Man, this got way better since the last time I used it. Scan assist, automatic scan parameters, tailoring, disabled full. Fast scan, stored offsets. I'll just use scan assist. File size limits. Cool. yeah, the Havoc implant was tiny, so. Let's see if we get any matches. Actually, while that's running, I'm just gonna go for a quick bathroom break. So I'll be right back. So, okay, so we got one sample hit. It looks like in May. And they identified it as Havoc. And Clam AV identified it as Havoc as well. So for those of you who are not familiar with Unpack Me, it's a service from Open Analysis, and they will basically run a bunch of different automation to unpack a sample, and then they will give you that unpack sample, and now they have all this cool enrichment. So they have a bunch of Yara sigs that are built in from places like Malpedia, and then they also have a bunch of different metadata and like kappa outputs and stuff. So you can see like this sample uses AES. It does in-memory parsing and PE structures, which is what I talked about earlier. It enumerates P sections and stuff like that. So, okay, so let's download this sample, and then I'm gonna open it in Binja, and then we'll see if it has a similar structure. So let's see if download. I'm just gonna move that to the folder that I have all my stuff in. And I'll just extract that here. Okay. And then 9.8. Okay, 693, right? All right, so it's a DLL. And let's open that in Binja. Okay. And then let's check out the start function here. So the DLL probably looks a little bit different than the one that we generated, but it should still have the same config. So I'll open the strings view here. And then we want this guy. Oh yeah, so not very exciting. It just has another local IP, but our parsing code should be able to parse this in theory. So we'll do our, there we go. So that's kind of why we wanted to be really tentative with the config parsing or the structure parsing. So then it'll be stable across different builds. So now we can see this is a HTTP post method, and again, like I said, it's kind of lame because it's just a local IP, but we can try some other stuff here with the Yara. So maybe let's just try the stack string and then add one more. We can probably improve upon our string, or sorry, our detection here. Another thing we could check is the stack string ops in the sample that we also detected. Or well, I guess they'll always be the same, so not really super constructive, but I think the injection target length is probably gonna differ if people customize their implants, so it's not great to detect on that. Let's see, we do this guy. I guess we could just mask out the last byte. B9, or not the last bytes, but the preceding bytes. B9, mask, and then just do 88. think we're gonna get a lot of false positives though. Maybe I'll add in one of those hashes. Get token information. All right. So let's see if we get a couple more hits this way. Still only one match. I'd be surprised if there wasn't more structure-based Yara. What do you mean by structure-based? Like the config structure, or? Let's do, go back. All right, let's mask out the registers. Oh, my headphones just died. Let me just grab my other ones. All right. Like getting the mnemonic hex order, some specific function or struct. Yeah. Whether the stack pushing values. I see what you're saying. So I would use the config parsing operations, but those aren't using relative offsets because they're using those like weird walks things. But I could probably find something else. Let me try this rule first while I do that. All right, I think that should work. So the 4C is the character that's being pushed on the stack for the stack operations, and then the hash. So let's try that. I don't know how many hunts I have left. But I'll probably try and make the rule more broad after this, instead of just using 2 operations. All right, 26. Sality, lockbit, and then there's no more regular Havocs. We can try looking at these unknowns. 12 megs. 12 megs is a lot. We can still look. Packed sality. Yeah, these binaries are big. Maybe this one. 229K. Agent Tesla. Yeah, I don't think this is the same. Let's see if I can find those bytes that I matched on. Yeah. This thing looks obfuscated. Gotta go, works at 7 a.m. here. This is, yeah, thanks for coming, Confuser. Appreciate it. Thanks for hanging out and chatting. All right, I don't think this is the Havoc. Okay, so I could probably see if I can find more Havoc samples. Sorry, I know that's tiny text, but I'm just like moving shit around. It's not important. Basically, I just want to move the confirm Havoc stuff into a folder. And then I'm going to save this IDB, BNDB, I mean, not IDB. All right, so it's 11 o'clock. I've been streaming for almost 3 hours. I wanted to kind of get started on the dev environment. So, okay, that's kind of where I wanted to get with Havoc. I guess we could write something to generically identify the function that references the... Yeah, maybe let's do that and we'll finish things off. And then I'll probably work on the emulation stuff. Maybe just talk about it next stream. But why don't we generically identify the function containing the structure, referencing the structure, and then we can call it. Because that won't take very long. Well, at least I hope not. So basically I want to automatically identify these struct offsets within our two samples. So let me open that up again, or in the wild sample, and then the one that we generated. So let's see, get back to our parse config. So there's a few ways we can do this. Typically, I'll use different references in the high-level IL. So we're going to use the binary range API to identify these functions, by the way. And so with that, we can use their high-level intermediate language or their ML, IL, or what have you. And we can do that in a number of different ways. So there's things like fingerprinting based on basic blocks, which I kind of like. There's things like fingerprinting based on functions that are called, so like the number of mem sets or mem copies or what have you. I've done some fingerprinting based on like these unique if statements and call sequences. So why don't we just do, so like if you look at the graph view, this is kind of the basic blocks from the, oh, take care, Cosmodium. Thanks for joining. Appreciate it. These are basically the basic blocks of the high-level intermediate language. So we could do something like that. We could even just look for, so I've modified this a lot, so I kind of want to look at it from this one that I haven't modified the structure at all. So let's do, how did I get to that earlier? I just found it through the strings view, right? So this is our config. This is our config parsing function. So we can even do something like the first instruction is a 0 assignment. So the byte length here, followed by a mem set or something. So just to show you kind of what that looks like, I can do like current IL instructions. And then our current function, and then we can do current IL instructions. Is that one? Cool. Okay. So this will give us the entire list, but we can do that. We can basically fingerprint that the first thing in this function is a high-level declare. Oh, sorry, no. Let's just do it the correct way. So current function dot HLIL dot instructions. So this will give us all the instructions in the function, and then the first one is a high-level intermediate language var init. So, and then it's like initialized to 0. So we could probably see how often that occurs. So if I say, let's just do a new snippet here, then we'll do like for instructions in all right, so that's actually giving me everything. So we can do BB, so we can do for all the functions, get the all the instructions, and then for all the instructions, if the first one is a, what did we say it was earlier? Okay, so if it's a high level IL varnet, then printf. All right, so it occurs quite often, but then we say if the second one is a variable declaration. Okay, so also happens a lot. But then if the third, or if, let's just say if the third is 0, 1, 2 is a call. Okay. And then if that call contains memset, in all the tokens, so I probably have to flatten these. So let me do oh shit, there's a bunch of memset. With a memset of, let's just say if there's like 4 calls in a row. This is pretty stupid, but so I'll have an init call. All right, that's good enough. So let's use that. And then we'll, again, this is kind of gross, but return F, and then we'll do okay. We'll see if it finds it. This sample, and it does. So it's pretty good fingerprints. And then we're just gonna get the offset of our second call here. So it'll be F instruction. Let's see. 1, 2, 3, so it'll be 2. Config. So that's the configure reference call, since it's referencing this pointer here. So we actually want to grab this third parameter here. So it'll be 1, 2, 3. So it'll be config ref call dot params, or we want to do so I'm just prototyping everything here in this window. So A is none if A is equal to F instruction 3 A dot params 1 value dot value. And then if I print this out, so that's the offset of our config address here. So now we can just do params value. And then find parse func. And that should give us that address. List index is out of range. Okay. Let's do so it's just airing out because there's some functions that don't have this number of instructions. So we'll just say is greater than 10. I know magic values are bad, but return outside function. Print it. All right, so that's going to be our address of the config. As for getting the actual size, we can probably avoid doing that for now. There's probably some padding. Yeah, not really. There's these bytes, but I think there might be, okay. We could probably get away with setting the size to the default size for now. So that would be this address minus this address. Did that wrong. 536. So we'll say like let's just say like 600 bytes. 600 bytes is fine. I guess maybe more in case the injection path is bigger. So like, let's just say 1024 bytes. Okay. Okay, and then let's get the rest of our code here, and then let's call this, let's put this into an actual function. All right, get structs, parse config struct. Okay, and then we'll do we don't actually want the address, we just want the size. All right. And then we want to extract string function. We need our data. There we go. Okay, so just to recap what I just did. We hadn't written any code to generically identify these functions in a Havoc payload. So, generically identify the parsing function for these configurations in Havoc payloads. So I just wrote like a quick heuristic that would basically say, look at all the functions in the binary ninja database, get all of the high-level intermediate language, so these like decompiled instructions. If there's more than 10 of them, which there will be in this parsing function. Check if the first one is a initialization, so this byte length equals 0, followed by a call, and then another call. So that's just a decent way of fingerprinting these. Then it gets the reference to the third one, which is the call to this mwconfig struct function, which has a pointer to this Havoc config. So once I get that pointer, I return that value. So I'm accessing the second parameter, which is at index 1, which is here. So the second parameter of index 1. I'm returning that from this function. I'm acquiring all the bytes from that start address up to 1024 bytes. We could probably get a lot more complex with this parser, but I've just set the max config size of essentially being 1024, and then we just use our parsing code to basically parse up until the first host. So I'm curious to see if there's multiple hosts in the Havoc config, what that would look like, but basically we just add a for loop for the number of hosts, so this number of hosts, and then iterate over the or parse each host string up to the number of hosts defined in this struct field. So maybe we can do that at the start of next stream, but it's pretty late here, so I'm probably going to call it. If anyone in the chat wants to come hang out, I'll just shoot our Discord. Thanks, Russian Panda. Thanks for coming. Have a good night as well. Yeah, you can join our Discord. And so I do malware analysis training. So it's part of this kind of educational content stuff. But if you want to check out the malware analysis training, you can go to the website there. And this is what it looks like. Introduction to malware binary triage. There's a bunch of different modules on how to do this stuff. I'm currently, this version uses IDA, which we did not use today, but I'm currently rewriting this to use Binary Ninja, which we did use today. So I wanted to do more stuff with IDA this stream, but kind of got bogged down in the automation here. But yeah, I even set up like a whole dev environment for my IDA instance with a bunch of cool stuff. So probably do more of that next stream, or kind of show you what I had in mind for the Garble emulation next stream. But until then, thanks so much for joining, and I'll talk to you all later.